Hello, everyone. Thank you for joining us today as we come together to learn more about Kubernetes best practices. My name is Houssem. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft, partners, and the open source community. It's also home to the Microsoft for Startups program, with a diverse mix of hands-on workshops, expert panels, and community events. There is something for everyone. Check out our calendar of events on meetup.com and join our coming sessions. Our speaker today is Houssem Dellai. Houssem works for Microsoft as a premier field engineer focusing on Kubernetes and DevOps. He was nominated and awarded the MVP award, Most Valuable Professional, for 5 years in a row. He actively speaks at conferences, meetups, and technical discussions. He shares what he learned also on the field on YouTube. So check out his channel linked in the Meetup description. Feel free to ask questions during the session. We will have regular stops to answer these questions. And also feel free to tweet about the session and tag us on Reactor Abu Dhabi. That's the hashtag. And MSFT Reactor is the Twitter handle. Make sure you also adjust the playback settings to select the highest quality for the best experience during the session. And with all that said, I hand over the mic to our speaker to start the session.
Thank you, Houssem. So welcome everyone to this session. Again, this is the third session about Kubernetes, where the first session was about an introduction into Kubernetes. The second one was about more on the operations on the CI/CD side for Kubernetes. Today, we'll continue on that path, on that learning path. And the session for today is going to be about the IKS best practices. Now that we have started using Kubernetes, we have implemented it. We have some applications that are already running in our cluster. Now we want to think about what are the best practices. How can I make sure my applications works as I expect? How can I make sure my cluster will be always up and running? How can I manage everything related to security, related to the best practices for the CI/CD, for high availability? What are the parameters that I need to check in my Kubernetes cluster? And I can't tell you, Kubernetes it turns out that the principle is simple, but the tools available there is actually lots of tools that you need to install in your cluster. And some teams or some development teams, they just miss some of these tools, and it turns out that most of those tools are really useful for your cluster. And the objective of this session today is to help you to get these tools and also help you to configure your cluster the right way. So the presentation is going to be about some presentation for those tools and how you can use them, and I'll give you also some resources to learn more about these tools. So let me get started first by here. I'll start sharing my screen. Let me know if you can see it. So I'm sharing my main screen here, where here I'm sharing the website for the CNCF. CNCF is the Cloud Native Computing Foundation, the organism that maintains the Kubernetes project. And CNCF, they not only maintain the Kubernetes project, but they maintain also some couple of other projects related to Kubernetes. And what they have provided here is this nice landscape. This is my favorite tool, actually, in order to choose the right tools to use in my Kubernetes cluster. So from here, let me know if you see my screen. Yes. I hope you can see my screen. I get yes, so I suppose you can see it. So from here we get the different tools that we can use with Kubernetes, and those tools are grouped by category. So if in your cluster you want to use a database, then In this landscape, you will find all the databases that are supported in Kubernetes. Those databases can run in a container. So let me go into here, for example. So those databases can run inside a container, and the provider for these databases, they have provided support for running those containers into Kubernetes. So maybe they will also provide the Helm charts that go with it, and into those charts they will implement the best practices for the different objects that should be implemented in your cluster. If you want to use some streaming and messaging tools, then here are some of the tools you can use. If you want to build your application and to use some tools for building the images, then we tell you here are some of the tools you can use. And you can see here, you can note that some of the tools are put in those squares, and some of them they have this blue blue on the edges. This means that this project is supported by CNCF. So all the other projects are not supported by CNCF. It's there is either a community or an enterprise that developed this tool, but the one that is inside the blue box here, it means that this project is maintained by CNCF, and that means that it have a first class support in Kubernetes. So whenever you choose, when you make your choice for one of these tools, I would somehow recommend to use the ones used or maintained by CNCF. There is some other, actually in CNCF you have different level of maintainability or different level of support. So either they are CNCF graduated project, those are the blue boxes, and the one in this blue box here, those are the projects that are not yet graduated. So CNCF started working on this project, build packs, for example, and it's not yet released as really available and really graduated from CNCF. So here we give you the tools, all the tools in one landscape that you can use in your organization. So let's see some of the other groups here for monitoring and for monitoring and logging. So let's see for logging, for example. So this is some of the tools here are already familiar to you. So either you are using Elastic, the ELK or EFK suite. Maybe you are using Grafana with it, Logstash, and lots of other tools that are available here. So you use the tool that you are already familiar with. And again, don't forget the first tool somehow should be the one in the blue box. So in today's presentation, we'll go to take a look at the most of those groups to explain why they are interesting and how we can implement them into the cluster. We won't see a demo, but I'll show you the resources that will help you to do the implementation side. So first, before starting with those tools, let me remind you about the experience of working with a Kubernetes and the cloud provider. So here I'll take as an example a managed cluster on Azure. So we'll be using the AKS service, Azure Kubernetes Service. And here I'll show you how you can create the cluster and what are the parameters you can configure on your cluster. Then we'll explain the architecture of Kubernetes cluster. And from that architecture, we'll start to see some of the discussion points or some of the problems that we'll discuss later with the tools. So here I'm inside the Azure portal. I'll go to create a new resource, and on that resource, if I go to containers, so we have here different services for running containers. Either we use container instances, and here I'll go to choose Kubernetes Service, AKS. So I'll go with that. And from here, we have some couple of parameters. First one is the basic parameters. So here you choose your Azure subscription. I have multiple ones used for demoing. So I use this one, Visual Studio Enterprise. And then for the resource group, I create a new one and I'll call it a Reactor. Hit OK. Then for my cluster name, I call it AKS Reactor. And then for the region, so here comes the first interesting parameter here is the region of your cluster. And this is really, really interesting to choose the right region. As we know, Azure today is available in 61 regions per today. And you should choose the regions that is near to your customers. Maybe you are a company based in Europe, but maybe your customers are only on US. So you should choose a region that is near to your customers in US. And even in US, we have multiple regions. So you choose the one that suits best your needs. And that's for the first recommendation to reduce the HTTP latency, because your users will connect from their laptops to access the website or the backend of your app, and then you want that HTTP request to have to travel in less time and to do less distance. So choose the cluster that is near your customers. In some other cases, we have customers around the world. So in those cases, it's up to you to choose. That's if you want to choose only one cluster, but you can also choose multiple clusters available all over the world. And then you can have some sort of route traffic. So you can use Azure traffic route in order to route the HTTP requests from the customers to their nearest AKS cluster. So here, let's continue with West Europe. And then we have here the Kubernetes version. And this is also important. So as we see here, we have multiple versions of Kubernetes. And Kubernetes, the project, Kubernetes, they release a new version, a new minor version each 3 months. So each 3 months, we have 1.19, 1.20 in 6 months, and so on. And here we have the latest versions will be always in preview because the cloud provider needs a bit more time in order to test the new releases and to make sure that it works as expected and with their resources. So the supported version is not always the latest one, but it's like 2 versions or 3 versions behind. So today, the latest one is 1.18, but we have 1.16, the latest version supported. So here, what should I choose? Should I go for 1.14 or 1.16? What do I choose? So here, the recommended is to go for the latest one supported in GA, general availability. And that should be, in this case here, 1.16.9. And keep in mind here that the support, we don't support all the versions available here. So if today we have support for 1.16, that means support for 1.13 and below will not be supported anymore. We support only until n-2. So we support the latest version before the latest in general availability and the one just before. Okay, so keep that in mind, and that's actually to force customers to upgrade to the latest Kubernetes version, because that's important, because the latest versions, they will have bug fixes, they would have also security fixes, and this is really important for us. So here I continue with the latest one supported, 1.16, and then here for my cluster, for the resources, for the virtual machines, I'll go to choose the node size, because Kubernetes is a cluster. So from here, I can choose the node size for my virtual machines. And note here, we have a selection of virtual machines. Actually, we have 206 virtual machines, and we can see all the list in here. But despite that, we have all those numbers. We suggest that you choose one of the VMs available in here, because those are the recommended ones. And for the choice of the VMs, you have actually two things to take into account. First one is you should ask yourself what you need this VM for. So if you need it to run some GPU intensive workloads like machine learning, AI model training, then in those cases you will need a GPU enabled VM. The GPU is what you need. So from here you can choose one of the VMs that is GPU enabled. So you see here we have categories of VMs, and you should look for the one that have the GPU enabled from this list. In other cases, you need more CPU power, more CPU capacity, so you would choose the right one for you. The second way to choose the best VM for your cluster is to actually to not take very large VMs, because here, if I sort this onto the RAM, you would see VMs that have 430 gigabytes of memory. That might not be the right VM for you. And here comes the question, what should I choose in my cluster? Should I have multiple VMs with less capacity, or should I have few VMs with big capacity? And the best answer for this is that you should just choose the right middle behind. Unless you have a container that consumes like 50 gigabytes of memory, you don't need to have a VM that have 400 gigabytes. Maybe just 16 gigabytes or 32, that would be enough for your needs. And some teams think that if they have less VMs that have larger capacity, that will be better for the cluster management and that will reduce the cost. Actually, no, that's not right. In Azure, and I'm talking here specifically in Azure, if you choose 10 VMs and each VM have like 8 gigabytes of memory, that means 80 gigabytes of memory, their cost would be the same as if you have 20 VMs with each one would have 4 gigabytes of memory. When they have the same capacity, it's the same cost. Okay? And here we need to take into account another parameter in Kubernetes. In Kubernetes, you should check with your cloud provider, but you typically have a maximum number of virtual machines that you can create on a cluster. On Azure, I believe it's around 1,000. So take that into consideration. And there is also a default number of VMs that you can create per cluster. So choose wisely the VM size for your cluster, and the VM should be either optimized for GPU, for CPU, or memory intensive work. Then we have the node count, and this is also important. Why? Because here for the node count, we can go from 1. So what should be the best count for? So this will depend, of course, on the applications that will install on the cluster. How much or how much capacity we'll need on that cluster. So if we say, for example, we'll need to deploy like 50 containers, and for those 50 containers we need 5 virtual machines, then the recommended number here would be always n plus 1. You need 5 VMs to run your clusters, to run your applications. Deploy 5 plus 1 VMs. Why? This is important at the time you will update or you will upgrade your cluster. Why? Because when you will upgrade your cluster, the way the upgrade works is through actually Azure, when it have 5 VMs to be upgraded into the latest Kubernetes version, it will start with the first VM. It will drain that VM. It means it will deploy the containers deployed on the first VM and a new container and a new VM. So it will create a VM number 6. It will deploy the containers into that VM, and In that case, sometimes crashes might happen. So in that transformation, you might lose your VM. So it is always better to have an additional VM in your cluster. This is typically especially for your production workloads. So think always about adding an additional single VM in your cluster to be used when additional capacity is needed. So here I continue with 3 VMs, that would be okay. And then I go for the next section, which is here the node pools. So for the node pools here, Kubernetes by default, it uses Linux virtual machines. And that's what we can see here. But we can also add other nodes that use Windows virtual machines, Windows containers. So here I can add those, and I can add that into another node pool. A node pool is like a group of virtual machines that will compose my cluster. So here I can choose Windows, and I can choose that in order to run my legacy.NET applications or to run my database that runs SQL Server and scenarios like this. Then here for the virtual nodes. So this is, we'll discuss this later when we'll go to discuss the scalability of the cluster. This will allow me to scale up to infinity my cluster. So I can run the number, a high number of containers on my cluster, even if I don't have enough capacity. Virtual machine scale sets, that's the recommended way. And then let's move to automation. Authentication, sorry. So in Azure, we support two ways for authentication. The traditional way was service principal, or the SPN. And with service principal, this is a resource in Azure that grants the cluster access to other resources. That's what we can use in order to authenticate into our IKS cluster. The problem for the service principal, it was that it's a bit tricky to manage, and it expires by default. It expires each 6 months, so you need to update it. And if you forget to do that, then your cluster will stop working. So for that, we have here this new way, which is the system assigned managed identity. At the end, this one actually will, behind the scenes, this will manage a service principal for you. So this is like service principal as managed service. So it's, of course, it will be easier to manage for you. So you don't need, for example, to renew it each 6 months. It will be done for you automatically. And with that, we have here the option for the rollback access control. And this is really, really important in Kubernetes. The airbag, it's always recommended to enable it. And airbag here is what defines how what access my developers would have on the cluster. Will they be able to deploy containers? Can they change the Kubernetes configuration? Can they add or remove some VMs? So all of those access control, all of those operations could be managed by airbag. So later in airbag, what we can do is that we can use the Kubernetes YAML manifest files in order to create a group of users. And here, this group of users could be created through Azure Active Directory. Because in your organization, you have always, let's say not always, but typically you would have an Active Directory in your Azure subscription, and you have all your users or your developers or your employees already on that Active Directory. So you can create a group of users for the Kubernetes administrators, and another group, another Active Directory group for your developers. So you give the administrators access, like to be able to change the configuration, to add, remove VMs, and so on. And the developers, the only thing, they cannot do that. The developers can only deploy containers into the Kubernetes cluster, and they can run container commands like kube control logs, kube control describe, kube control get, in order to be able to interact with the cluster. So keep in mind to always enable airbag. Let's move to the next section, which is networking. So here, from here, we have actually two Kubernetes implements two ways for networking. First one is the basic. This uses the kubelet, and then we have an advanced mode that will use that will leverage the virtual network, the VNet in Azure. And here, yeah, it's up to you to choose. Just take into consideration that with the advanced mode, you need to program, or you need to ask yourself. You need to plan ahead for the IP ranges that you would give into your cluster, because that would be managed by the virtual network, by the VNet. In most of the cases, using the basic networking configure, the basic plugin would be actually enough. And then here we have configuration for the private cluster. What this means. So by default, AKS will give you a public URL to access your API server to be able to interact with the cluster from your machine. And that public URL, because it's public, it's exposed to the internet, that will expose your cluster. And that some ways, some security teams, they don't allow that to happen. So what you can do here is that you can create a private cluster, and then you can connect to that cluster from a virtual network in Azure. So in that virtual network, you join your Kubernetes cluster, and also you can deploy a virtual machine into that virtual network, and that virtual machine can connect to the cluster because it lives inside one single VNet. Here I'll continue with the public cluster. That's fine for me. And then we have here the network, the choice for the network policy. So for the network policy here, we have two choices actually. Either you don't implement that in your cluster, or you choose between Calico and Azure. We'll talk about Calico later, and the objective here behind network policy is that you can define policies that says, for example, your pod number 1 can connect to the pod number 2, but it cannot connect to the pod number 3. So that's like creating firewall rules for your applications that will allow to create isolation between different applications. Let's now move to the integrations part. So here, when we use Kubernetes, we always because the only way for Kubernetes to get the images or to get the Docker images is from a container registry. So for that, here from the portal, we give you the option to create a container registry from here. So I don't have one, I'll go to create a new one, and I'll give my container registry a name. I call it Reactor ACR, for example. Let's check if that name exists. Yes, it did. And then for the resource group, we'll use the same resource group as my cluster, the same region, and this is really important. Here you want your Kubernetes cluster to live inside the same region as your container registry. Why? That's again to reduce the HTTP latency for your cluster, because the cluster will download the image, so it would better be inside the same region or even inside the same availability zone. So we'll choose the same region here, and then we click OK. Then we have other options related to container monitoring. So for monitoring the cluster, this is the #1 question for the developers and for the operations team, is how can I monitor my cluster? So we have a couple of options. So as we have seen in the CNCF landscape, from here we have some tools that enable you to monitor your cluster, and it's up to you to install those tools in your cluster. But here in Azure, we give you the possibility to just check the button, and then Azure will implement that into your cluster and will give you a dashboard available from the Azure portal to monitor your cluster. I'll go with that enabled, okay? And that will use log analytics in order to get the logs from your containers and then save those logs into Azure. So you don't need to implement yourself the database for saving the logs and routing the logs into the right dashboard. Great. Once we have done from here, Azure will go to check and verify what we have entered. Once that's verified, it will go to start creating the cluster and the container registry for me. This will take from 3 to 5 minutes. Let's give it some time and let's check if we have some questions in the Q&A section. Any questions here? Let's move to the Q&A. So first question from Raja, is there an amount of memory CPU that would be reserved per node for Kubernetes services? Indicate 224 of memory for machines. Yes. So for your question, yeah. So when we tell you have 7 gigabytes of memory per machine, this doesn't mean that you would have all the 7 gigabytes actually. Because yeah, Kubernetes will install some agents or will install some containers that it will install the kubelet, for example, and those resources used by Kubernetes master plane or the control plane itself, they will consume some resources from your virtual network, from your virtual machines. So you should take this into consideration actually. When you have bigger number of virtual machines, you would have more memory that is utilized by Kubernetes itself, that is reserved for Kubernetes. So when you have 7 or 8 gigabytes of memory per machine, that doesn't mean you have really 8 gigabytes of memory. Maybe you would have something like 7 or a bit less. So yeah, nice question. Thank you for pointing that out. Yeah, next second question from Luna. Can you choose Docker Hub or such to get containers from your container registry, Azure Container Registry? Yes, so here in AKS, I have chosen to use Azure Container Registry, and that's a managed container registry available on Azure. But of course, Kubernetes can get the containers from any container registry. Container registry is like a standard implementation, so that could be either Docker Hub or even a container registry from other cloud providers or something else like JFrog or so on. Good. Let's now move to another section here where I go to explain a bit more about the Kubernetes architecture. I have drawn this before, but I want to do that again here. So go to draw. So the Kubernetes cluster is the group of virtual machines. So here, those virtual machines are called node in Kubernetes, okay? And those are actually multiple virtual machines. They could be with the different sizes. Let's write that correct. So that should be VM or node. And on each of those nodes, we have actually Docker that is running in here. So we would have the Docker runtime already installed. because at the end we want to run Docker containers on those virtual machines. So we can do that when only we have the Docker runtime already installed. So Docker installed on each virtual machine. And then those virtual machines will be controlled by the control plane, which is another virtual machine itself that is available here. So we would have this control plane. And this control plane will manage the worker nodes. So when here a developer that wants to deploy an application into this cluster, what he would do here is that he would write the YAML configuration files. And into those files, he will put the configuration for his application. So maybe he want to deploy an image that uses Nginx, for example, and he wants a number of replica to be, let's say, 5, for example. Then he would use here the kube control in order to deploy that YAML file. So from here, we'll be using kube control, which is the command line used to interact with the Kubernetes cluster. And then the control plane will receive that file. It will read its content, and it will use here the main component, which is the API server. And through it, it will use another component available in Kubernetes, which is called the scheduler. And it will understand that it needs to deploy those 5 containers into the cluster. So using the scheduler, it will check for the available capacity in the different virtual machines. So for that, it will use actually another component in Kubernetes called the kubelet. The kubelet is what allows the control plane to communicate with the worker nodes. And the kubelet is installed as let's say a daemon set in each of those virtual machines. So it will go by this configuration. Maybe it will go to deploy, let's say, 2 containers into the first virtual machine, and then 2 other containers into the second virtual machine, and the last container will be deployed into the last VM. Great. So, but here actually you have, so now for our users, when they want to access this this application, they would connect from their modern browsers. So they would use right here. Let's add those users. They will use here Internet Explorer 6 as a modern browser in order to connect to the Kubernetes cluster. So here they would use, they won't actually connect directly to the cluster. No, that won't be done like that. But they would go through a load balancer in order to access the Kubernetes cluster. So in the middle here between my Kubernetes and my users, we would have something like Kubernetes load balancer. And the load balancer is the one that will manage the traffic to the different containers. Great. So from here, for the API server, when it gets this YAML file, it reads that it would deploy the Nginx, and on the first try, the Nginx is not available inside the cluster, but it's available inside the container registry. So for that here, we have to look about the container registry as another component that could be created by the cloud provider. So here that could be ACR as a container registry. Let me write that here. And from inside this container registry, we have here the Nginx image. Maybe you have some other images for the app. Maybe another image for Java, for example, and so on. And that container registry would be connected to our Kubernetes cluster. And the way to do that, to establish that connection, is actually through using the managed identity that we have configured earlier in the Azure portal. So that would be through using identity. And what this will allow you to do is that typically when you want to connect to a private container registry from Kubernetes, you would put the login and the server name and the password inside the YAML file. And that's not a good practice to do. Okay, so to avoid that, we use the identity in order to manage that authentication for you, because at the end you would use that password in order to authenticate and to be authorized to pull the image from the container registry. So using the identity, we can remove that password for the container registry from your YAML manifest file. And that's really a good feature available in here. Great. So that's gonna be the architecture of our cluster. Then there is actually some other parts of this cluster. So if here we talk about the cloud API, or the provider API, this one actually will go to talk to the Azure API, or the Azure ARM. And it will talk to the Azure ARM in order to create the resources that I need to run my cluster. So from those resources, we can say here the virtual machines, the different VMs, which are the VMs for the worker nodes, and also to create the load balancer, because the load balancer here at the end is an Azure resource. So that would also create that load balancer for me. And then there is some other components that are not that are hidden in my architecture here, like the virtual network, which will allow pods from the first VM to connect to the pods from the second VM. Okay, and that could be done actually through virtual networks. So into here, we would have a network that will connect those different VMs, and that's called VNet, the virtual network. And that virtual network is another resource that is created by that cloud provider. We have some other resources like the disk, and we talk about the disk here when we want to persist data in our cluster. So when we work with databases inside container, we need to persist the database inside an Azure disk. So for that, we need to attach or to mount a volume on a disk into our virtual machine. So in here, we might have one of those virtual machines that connects to an Azure disk. And that's actually through using the persistent volume. So then we would have our database hosted inside that disk, either database or files or whatever you want. Great. So all those will be managed by the cloud API through the Azure API or the Azure ARM Resource Manager. Let's now go back to our cluster and let's check. And here we find that the creation or the deployment is complete. So I can go to resource. And from here, I get access to the Kubernetes dashboard, to my AKS dashboard, where from here I can go to view the node pools that I have created. And here we see the 3 virtual machines that we have created. We can also go to upgrade the cluster to a newer version. We can go to scale out our cluster, and I'll come back to this in a few minutes. And yeah, we have some other useful options like here, from where you can get the insights and the metrics and the logs coming from containers inside that cluster. But here, I want to take you into another resource group. We're here actually in AKS, when we create a cluster, that would create 2 resource groups. So we have called that the Reactor. I have called it the Reactor AKS. So here I have the Reactor resource group, and there is actually another resource group that starts with MC, and that's this one here. And this resource group will contain the Azure resources that would be created for the cluster. This includes those resources stated here. And that's what we can see from this window in here. So I can see that here we have a virtual machine scale set, which is the group of my virtual machines. We have the virtual network, the VNet, and we have the load balancer. We have identities. We have a network security group, and we have also public IP to connect to the API server. So because at the end, AKS is a managed Kubernetes service, so it's up to Azure to create all those resources and configure them to run correctly your cluster. And of course, you can go to change this configuration, but it's actually recommended to do that through the control plane, not directly from here. Great. Let's see if we have some more questions. Another question. So from Alistair is asking, is there a free tier option to try this out before getting charged? Free tier for AKS, I'm not sure, but what you can do is that you can have a free Azure subscription. If you go to azure.com/free, from there you can create a 1-month Azure subscription, and you would have, I believe, around 100 US dollar or 150, and you can use that to try any Azure resource and available there. Another question, does the container registry have to be in the same subscription as the AKS cluster? No, that's not required, but that's recommended actually. In the same subscription, I would say in some cases that's not recommended because yeah, I see some companies, they use multiple Azure subscriptions. So they would have like an Azure subscription per team, for example, or an Azure subscription per environment, dev, test, and prod. And they would have a dedicated subscription for the shared resources. And from those shared resources, they would have a shared container registry that would be used by all the teams on that organization. And in those cases, it's not, in those cases, I believe it's fine to have that container registry live inside another Azure subscription. And at the end, Kubernetes can connect to almost any container registry that is publicly available. Another question, could we add container registries on the go? I believe this means that yes, you can create first the Kubernetes cluster, and then you can add or remove any other container registry to your cluster. So yeah, that's doable. Is there any guidance as to when you need to create another Kubernetes cluster? Is this split by projects or by regions or by max number of containers per cluster? Come forward to make you this. Okay, nice question here, and that's what I'm gonna discuss later, which is the physical and the logical separation between the clusters using either a multiple cluster or by using the same cluster with multiple namespaces. So in a few seconds, I'll answer that. And then another question, I'm still sort of new to Kubernetes, so this question might be beginner level, it's fine. Which node is the master node on? Is it within one of our nodes somewhere separate? Yeah, good question here. So in here, we see the virtual machine scale sets. Those are the virtual machines that are used as the worker nodes. So what you see here, what we have created the 3 virtual machines. The 3 virtual machines will work as the worker nodes, not as the control plane. The control plane, that's the virtual machine that is created by Azure for you, and it's managed by Azure. And we don't give you access to that control plane because it's the responsibility of Azure and to make sure that that control plane or that VM would work as you expect. Okay, so that's one of the definitions of the managed Kubernetes cluster, is that the control plane, it would be managed by the cloud provider. So you don't need to update it. You don't need to make sure you securely save your etcd and the other components in there. Another question. What happens when we remove the nodes after creating a cluster? Yeah, that's a nice question. So after we have started creating the cluster with 3 nodes, but you can add or remove nodes as you want. So from the Azure portal here, I didn't show you that, but what you can typically go to do is that you can go to your cluster, and from the scale window right here, you can go to click on this link, and from here you can check your agent pool, click on this 3 dots here and go to scale, and from here we have the 3 VMs currently running our cluster, but we can change that number whenever we want. So I can go to run only 1 VM or up to 100 or okay, but for now, until today, at least you should have at least 1 VM running your cluster. There is a plan that is coming, that will be coming in the future in order to support clusters that runs the 0 virtual machine, and that's in order to reduce the cost. So when you are not using your dev or your test cluster during the weekend, so you can scale this down up to 0, and then you won't be charged for virtual machine consumption in your cluster. So watch that for the upcoming features available. And actually, another good practice that I would recommend is to watch for the Kubernetes, for the AKS features that will be available later. So if you go to look for Azure/AKS, you go to this link, AKS projects. From here, you can actually see the product backlog for Kubernetes, for AKS mainly. So in here, you can see the backlog items, the planned items and progress, what is already in public preview and what is already deployed on the cluster. And you see here some, so before starting implementing some of the features yourself, you might take a look into here and you might find that what you want to implement is already on the product roadmap. So I would highly recommend to use this. I copy the link and share it into the Q&A. Yeah, here it is. Yeah, let's check. We have many questions actually. Let's check some of the other questions. So when you remove the nodes from after creating the cluster, actually, yeah, that will crash. That means you will your cluster cannot run anymore. Let's move to the other question from Lihan. What is the best practice to access services deployed on cluster? Load balancer should route requests to individual pods, or should the services be exposed as node port services and then load balancer should route to this node port service? Yeah, good question here. So typically we can use the service in order to route the traffic to the pods, but you can add also an ingress controller in order to take the route from the users, or in order to take requests from the users and then route them into a service. And yeah, for me, I believe that should be the best practice, because you would have multiple options available with an ingress controller, more features than what you get from a publicly exposed service through a load balancer. Because yeah, you can work with the SSL, so you can activate HTTPS and so on. Where can I find the master node? You won't see the master node because it's managed by the Azure. So you would only, but you can manage it from this dashboard here. Give you access to all the operations you might want to do on your cluster, like upgrades, the scalability, and so on. And you can also see the logs coming from that API server. So in Azure, we have that feature available, and you can activate it from your IKS cluster. Great, okay. Let's now move to some other section for the best practices. So let's now start talking about the monitoring and logging. And that's the number one question for developers, because now when you will deploy your application, you would see those logs, okay? So what you would use there, again, you will go to the CNCF landscape, check for that blade for logging and monitoring, and then check the tool that you are familiar with or the tool you want to use, and then you can go to install or implement that tool into your cluster. For me here, I have written some 2 articles about logging in Kubernetes, and for that I use it in my demo. I have used EFK, Elasticsearch, FluentD, and Kibana. And I have a series of videos that shows you how you can, how that works, what are the different parts. So typically we would install FluentD as a daemon set on each virtual machine in order to get those logs, and then send those logs into an Elasticsearch cluster, so that Elasticsearch will save those logs into a database, and then you can visualize those logs using Kibana dashboards. So I have a list of videos and this article that will show you how you can do that. I'll share this article with you in the Q&A section. Great. And yeah, we have the source code files for how to configure that. So that's the number one thing to do on your cluster, actually. Then you have here the for monitoring, we can use one of the tools that we can use is Prometheus and Grafana. Those are supported by CNCF, and the way they work is that we install Prometheus on the cluster, and then Prometheus will start to scrape metrics from the different virtual machines. So we have that component called node exporter that will be installed inside the virtual machine. It will read the metrics provided by Kubernetes itself, because by default Kubernetes will expose some metrics like the CPU utilization, the memory, and the network metrics. And those will be collected by Prometheus, save it in its database, and then we can use Grafana in order to connect to the Prometheus database and get those metrics from there, so we can have queries or dashboards that will show us the CPU and memory utilization coming from our cluster. That dashboard will look like this one in right here. So you would have nice metrics in order to make sure your cluster is up and running. I send you this link again here in the Q&A section. Great. And then I'll move to another part, which is the network policies used in Kubernetes. So in Kubernetes, we can deploy one or multiple applications. And the first requirement, the first security requirement is that those applications should have a boundary, or they should be isolated. Resources from application 1 should not be able to connect to resources from application 2. And let me go back to my dashboard here, to my OneNote file. So let's say that here in our cluster, we would have multiple containers running. So I would have this container. And let's say this is the container for my front end, for example. And this container will connect to another container, which is the backend, for example. So we can allow for that connection. So that's allowed actually. But sometimes we would have another application that on its own it have a front end or another component called with another name, and that one will try to connect to its own backend. So what could happen in those cases is that sometimes accidentally that front end might try to connect to the backend of another application in here, and that should be disallowed. And what could also happen is that this front-end container might be compromised or could be hacked. So, and as we know in Kubernetes, if you have a container running in Kubernetes, it can actually reach all the containers deployed into your cluster. There is no isolation between those different containers. So that means that this front end can connect to this backend, can connect to this one, and so on. So in order to stop this communication, we can here use network policy like Calico. So with project Calico, we can create a policy. That policy will state that the front end, this one, for example, should be able to connect only to this backend. It cannot connect to any other container or to any other pod in our cluster. Okay. So when that pod tries to reach the backend from another application, it would be Calico will not allow it to do that. So that will ensure that we always have physical isolation or some sort of logical isolation from the different pods. And yeah, here you would say, because we would have multiple applications, we'll be using multiple namespaces. So this is namespace 1 and this is namespace 2. But even namespaces, they are just logical separation between the pods. They are not hard isolation. So applications from across different namespaces can communicate and can talk to each other. Great. So using Calico policy is really useful. And here I have created a video available on YouTube that shows you how you can implement it. So first you enable it from the Azure portal, as we have seen earlier. Then From there, you can go to start implementing some policies. So here we have a policy that will deny all access to all containers in your cluster. That should be the default policy. So, and then you can create some exceptions. So to say, for example, my front end can connect to my backend and so on. And here I'll show you a policy how that works. So here we have a network policy, which is a YAML manifest Kubernetes file, and that policy will get the ingress or will get traffic from those different resources. So it will get that traffic from a pod selector from any namespace. It will get the traffic, it will accept traffic from any pod that have the labels app, web app, and role front end. Okay, so again, using labels, we can define those different roles for the application to say this is the front end, this is the backend, database, and so on. And the rest of this tutorial will show you some more advanced options to configure the ingress, the egress for your network policies. I'll share this link for you on the Q&A section. And yeah, here we get the question, how different is EFK from ELK? So when we have talked here about the EFK. So EFK and ELK are the same stack. The only difference is that F in EFK is for fluent D, and L in ELK is for Logstash. Those are the two containers used to scrape or to get the logs from inside the Kubernetes cluster. It's up to you to choose the one or the other. Again, from the CNCF landscape, it's clearly recommended here to use Fluent D rather than Logstash, because as you can see in this section, Fluent D is inside that blue rectangle. It means it's directly supported by CNCF, and it's a graduated project. Okay. Logstash should get some support, but yeah, it's up to you here actually. Great. Let's now move to another section into here, which is managing the secrets. And this is one of my favorite topics. In Kubernetes, we can use secrets, right? We can create a secret. I'll show you one secret in here in this project. So here I have some Kubernetes manifest, where if I go to show you, so actually, let me first show you the config map. So when we have some keys in Kubernetes, we can save those into config map, and that's like a database that saves your keys as key value pairs. So here we have connection string, and we have the value for that connection string, and that connection string, it have password. And of course, it's totally bad to put that password as plain text inside my YAML file. I need to protect it, because this now is exposed on my GitHub repository. It's exposed to all my developers, and my database could be compromised. So what I would do here is that I want to protect that password. So first solution provided by Kubernetes is that I can use the secret object. The secret object will save data as key value. So here I have the key, and then the value for the connection string. And note here, the value is not in plain text anymore, but it's encoded using base 64. But again, base 64 is not enough to secure your values. It will just hide the values. It's like it's hashed, but you can reverse. You can reverse this encryption in order to retrieve the actual password from him. So this is not secure at all. A third solution provided by Kubernetes is that you can encrypt your passwords inside the Kubernetes cluster itself. And Kubernetes have the mechanism and have the tools to do that. But that actually stays, you would need to know how that encryption works. Okay, So then we have a fourth solution, which is more adapted and more managed, which is using an Azure resource or an Azure cloud resource like KMS, Key Management Secrets, which is a managed service that will manage the secrets and your passwords. And that is actually really, really easy to use. So in Azure, for example, we have the Azure Key Vault, and we can use that Azure Key Vault to save our secrets there. So into here, we would have our Kubernetes cluster, and that cluster will connect to Azure Key Vault to retrieve the secrets. So from here, we will get the secrets or the passwords or the private certificates and so on. And the Azure Key Vault is managed by Azure, so your secrets are securely saved inside Key Vault. And you can, of course, you can hide those secrets, you can encrypt them, and you can enforce rotation for those secrets to say, hey, I want to update my database password each 3 months, for example, or each 1 month. So even if when they are compromised, you can update it, and Kubernetes can notice that that update. So now how can we integrate that into Kubernetes? So to say it here, until today we don't have a native experience or a native native integration between Key Vault and Kubernetes, but there is this project called CSI Kubernetes, CSI Key Vault Provider, which I'll show you in a second here. So this is the project, Secret Store CSI Driver Provider in Azure. And this project aims to bring support for Key Vault into the AKS cluster. I'm happy to be one of the contributors on this project. And yeah, so here, this project aims to get Kubernetes to connect to the Key Vault and retrieve the secrets from there. So, and that the integration would be done through using pod identity, and you can write that configuration using the YAML manifest file. So here in this secret provider class, you would provide the name for your Key Vault, for your Azure Key Vault resource, and then the objects, which are the secrets you want to retrieve from Key Vault. And that's actually, so here we don't have any password written in plain text. Even the connection into the Key Vault itself, because you would, at the end, you would need the password for the Key Vault, that would be actually managed by the managed identity. So in here, for the authentication, that will use Azure Identity. So again, you don't, in Kubernetes, you don't have the Azure Key Vault password, neither the password for your databases. All of them, they are saved inside the Azure Key Vault, and they are managed in one single place there. And guess what? Even from sometimes in your CI/CD, you will need those same passwords. So you won't go to duplicate them into Azure DevOps or into GitHub Actions or your DevOps tool, but you can reuse that same Key Vault from your CI/CD pipelines. So here, if you are implementing CI/CD, you can connect again to that Key Vault, and you can get those same secrets if you want them to. So that's one single place where you put all your secrets. It's managed, so you don't need to worry about losing those secrets. And for some cases, you know, errors might happen. Someone might go to delete that Key Vault from the Azure portal, and what we give you here is that even after the deletion of the Key Vault, actually the secrets will still be persistent in Azure for at least 7 days. By default, it's 30 days. So we take care about your secrets in Azure. Great. Let's see if you don't have any more questions. Good. Let's move to something else. Yes, so just a word about Helm. I know I have talked about this in the last sessions, but when you want to deploy, there is scenarios where a Helm will be really so useful for you. So those are mainly two use cases. So first one is when you have multi-tenant application, you want to deploy the same application for multiple customers. Okay, and in those cases, you would be required to write the same YAML file multiple times. For each customer, you would have a different YAML file. You know, you would have his own passwords for the database, his own service names, and so on. So you'd end up with multiple configuration for the YAML files, and that's hard to manage. Imagine if you have 10 or 100 customer there. The second use case is when you want to deploy into multiple environments: dev, test, prod, QA, pre-prod, staging, and so on. So, and you want to customize the deployment. You want to customize the YAML files. So in those cases, Helm comes into play, and Helm can help you there to create templates for your YAML manifest files. So with Helm, what you can do, you can create variable files. So let me show you here a Helm chart. I have a sample available in here. So let me show you this one. So here I have values, the values that might change inside my template. So I have, for example, the image tag or the image repository. Those values might change. Okay, I might also change the Helm chart for my database and for some other configurations, the port numbers and so on. So what I can do, I can create a template folder, and in here I would create a deployment, and in there I would create variables for all the stuff that could change in my template when I deploy either multiple times or into different environments. And from those variables, we see here the image name and the tag for the image. Okay, so then we can customize the deployment depending on the environment or on the application. So that's highly recommended to use it. And you can also integrate that into your CI/CD pipelines too. Okay, and here by mentioning CI/CD pipelines, I want to show you just a diagram for how that works with Kubernetes. So in Kubernetes, you would have the developers writing the YAML manifest files from their local machines, and they will put those YAML files. First they will live in their machines, then they will push that into a remote Git repository. So in here they would have Git, and into here they would have the SRC and the deploy folders for their applications and so on. And typically when they create a new feature, when they want to create a new release, they will go through a pull request. So we configure here pull request or PR in order to trigger the CI/CD pipelines. So let's first talk about the CI pipeline and what should happen on that pipeline. So in the build, or let's call it the CI, and to here, what's going to happen is that we go to create the image and push it into the container registry. So we'll go to build, then push, and yeah, here should be running the Docker build, then Docker push, so that the image will be created and it will be sent into the ACR. So into here we would have the container registry, and the image will be sent into this container registry. So in here we would have our container live in here. Once that runs successfully, we'll go to run now the CD pipeline. And let's see what will happen into that CD pipeline. So this will trigger the CD pipeline, what we also call the release. Let me call it release in here. And from this release, we'll go actually to deploy into our Kubernetes cluster. So let me make sure here. So the release will go to deploy the YAML into the Kubernetes cluster, okay? So that will actually go to run the commands kubectl apply all create kubectl apply -f, and then we pass the YAML file into there. Those are the different commands we use. Okay, so and on the release we might either deploy into Kubernetes, or we can so at the end, yeah, we'll deploy into Kubernetes, and we can also deploy into multiple Kubernetes clusters or into multiple environments, depending on how we isolate those containers. And Kubernetes, in either cases, it will go to look for that container from the container registry. So it will do a pull operation here, Docker pull, in order to deploy that Kubernetes, that container inside the cluster in here. So that's simply how we can do the CI/CD pipelines in Kubernetes. So let's now move to another section where here I want, we have some questions. So how do you rerun Helm after updating the values? Yeah, so first time you would run Helm is that maybe you would use the Helm install command. That first will run successfully. It will install the Helm chart for you, but the second time you run that same command, it will fail, because it will detect that the package already exists, so it cannot install it again. So in that case, you should go to run a Helm upgrade. And with Helm upgrade, you pass a flag --install. So that means at first it will detect if the chart is not available, it will install it. And the next time it will detect that the chart is installed, and it will try either to apply the changes or to do nothing. If so, that's with Helm upgrade --install. Then you put the rest of the parameters. Does Azure Key Vault generate the required secrets? Actually, in Azure Key Vault, it's up to you to create the secrets. So you say you define a secret, call it database password, for example, and then you put the value for that secret inside Key Vault, and then Key Vault will make sure to encrypt that secret for you. Okay, so it will be hidden and it will be encrypted and secured by key vault. And then you can consume it from your Kubernetes cluster. Great. Let's now move to another section here, which is the physical and the logical isolation from different applications. So earlier we mentioned that when we have multiple applications, let's say my container would connect to another container, and those are part of the app one. Okay. I might have the same but deployed onto app two. So I might have container for app2 that connects to another container that lives inside app2. And both resources will live inside the Kubernetes cluster. So first step or first solution for me to isolate those resources is through using different namespaces. So I would have a namespace in here. I call it namespace 1, where I have the both containers for app1. And I might create a namespace for my my second containers. Okay. So this creates what we call the logical separation. This is called logical because actually with this default configuration, unless we use network policy, there is nothing that stops my container in here to connect to a container that lives inside another namespace. Okay, that's why we have talked about the network policy in order to enforce that isolation. So that's by default enabled on Kubernetes. So that's first solution to isolate applications logically. So both namespaces can live inside the same Kubernetes cluster. So let's imagine that here all of this will live inside the same Kubernetes cluster. Okay. And the second solution that we can implement in here is actually using the physical isolation. Let's see what that means. Physical isolation, we would still have the same containers, both from both applications that connects to each other in here, but instead of using just the namespace boundary, what I can do here is that I can create a cluster for each application or for each resources. Okay, so those are different clusters. So in here, this container doesn't have a way to connect into here unless I configure it implicitly in my cluster. Okay, and we can also combine between two. So let's first see when to use which option. So actually, it all depends on the number of the workloads you have, on the number of containers, on the number of requests required for your container. So typically, first thing to do here is that you would, let's say, always have a dedicated cluster for your production environment. That's the basics here. So the result of this would be to use Kubernetes cluster for prod that's isolated. Okay, and then you might have either one or more additional clusters for your other environments. So you would have another Kubernetes cluster for your pre-prod, for example. And some other ones for the other environments. You might have also another one for dev and test. Okay, so it's up to you here to define those non-prod clusters. But keep in mind that the prod cluster should be always isolated. Why? That isolation will help you to configure security. because here you can apply the least privilege security principle. So here you give access to only your administrators. Okay, developers cannot access this production cluster. Do not misconfigure it accidentally, for example. And on the other clusters, you can give your developers access to this one in order to try stuff either into the pre-prod and so on. So here you would have your developers being able to access those clusters. So that enforces security. It's not only about the isolating the different applications, but yeah, that enforces security, and that also keeps applications running in one namespace to utilize resources available for the second namespace. Because at the end, on the same cluster, applications will share the same resources. So unless you use resource quota, which specifies the requests and the limits of memory and CPU utilization for each container, the resources will be shared across those different containers. So you might have one container in your cluster that eats all the resources, one giant container that takes, let's say, 100 gigabytes of memory. So it will take all the memory in your cluster, and then all your other clusters will start to crash, restart, and yeah, that will drain your resources. Great. Let's see if you have any more questions. Yeah, good. Okay, now I'll move to my last recommendation here, my last best practice, and here we'll be discussing the scalability for the cluster. So in AKS, and that's the case for most of the other clusters actually, we have three ways for configuring scalability. So first level of configuring scalability is inside the cluster itself. So inside the cluster, I might deploy a pod or a container, let's say, and at first I might have only 2 containers running, but then I might need more containers to run my workload because I have more HTTP requests, or I have more messages in my queue, and so on. So, and here I would add more containers inside my cluster. And we can configure this through using the auto-scaling. So in Kubernetes, we have an object called HPA. HPA stands for Horizontal Pod Auto-Scaling, and configuring this in YAML, we can specify, let's say, the minimum number of containers, max, and to scale based on CPU and memory utilization. So when it detects it needs more containers to be deployed, it will go to deploy those containers automatically for me. So I don't need to do that manually. It's auto-scaling inside the cluster itself. So this is the first level. Second level of scalability is through adding more virtual machines to my cluster. So the problem with this first level is that maybe on my cluster, I have only capacity to deploy 1,000 containers, but now I want to deploy 10,000 containers. So this means I need more capacity into my cluster itself. So in that case, I go to my Kubernetes cluster, and here I can add more VMs in my cluster. And this is what we have seen actually from the Azure portal earlier when we have checked this option. If I go back to the Azure portal, where we here checked this option for scalability, where we have seen the manual scalability, where I can set the number of the virtual machines or the number of the nodes. But we have also another option, which I didn't show you, which is the auto scale. This will allow you to allow your Kubernetes cluster to auto scale itself. So here you can configure it with the minimum and the maximum number of the VMs. And the way this works is that when Kubernetes will detect that it needs more capacity, because I'm trying to deploy 10,000 containers and my cluster with the current existing resources, it cannot deploy all of these. So that will raise a flag in Kubernetes to say, hey, Azure, I need more virtual machines. For now, I have only 3. Those are not enough. So give me more virtual machines. And that's through talking to the Cloud API or the Azure ARM. So Azure will provision some additional VMs into my cluster, the match it wants. Okay, so that's the Kubernetes auto scaling, and that's not managed inside Kubernetes, but it's actually managed by the Azure API. So it's configured. You can configure it from either the Azure portal or the Terraform files and so on. Great. So this is the second solution, which adds more VMs. So either we add more containers, we add more VMs, or we can use a third solution available in Azure, which will actually extend the Kubernetes cluster with some additional VMs. But actually here it will add one single VM that have, let's say, infinite capacity, and that's using Azure Container Instance. Why we have this option where we can add more VMs into our cluster? Actually, it turns out that adding more VMs to the cluster that takes few minutes. Okay, something between 2 to 5 minutes, sometimes 10 minutes. Okay, so that's a lot of time, because in some cases I want to scale in just a few seconds. If I have that use case, then here I can use ACI. ACI will add an additional virtual machine that have, let's say, infinite capacity in just a few seconds. It will not need to wait for the time to deploy a virtual machine, because under the hood, ACI uses the serverless containers, what we call, this is serverless containers. So it means it can respond to events in just a few seconds. So it can be prepared in order to run those additional containers and required in our cluster. Great. So with that, I believe I have reached the end of this presentation. Let's check if you have some more additional questions about what I have presented. I hope it all was clear for you, and I would leave you with some more resources that you can use. So here in my YouTube channel, I have created a playlist where I have stated some of the tools that you would need in your cluster. So remember what you have talked about: the EFK, storing the secrets, monitoring, logging with Prometheus and Grafana, enabling Airbag in Kubernetes, and then the CI/CD using Helm packages, network policies, and so on. So in here you would find the videos that comes with more details, and more details also about the implementation of those tools into your Kubernetes cluster, so that at the end you hope you would be successful using Kubernetes, especially AKS, Azure Kubernetes Service, as a managed service hosted onto Microsoft Azure. So with that, I hope it was all clear and fine for you. And yeah, maybe we would have next sessions later in the upcoming weeks. So stay tuned for that, and watch out for the Meetup page for Microsoft Reactor, where we'll post the new and the upcoming sessions. So with that, I would say, yeah, thank you again for watching this one. It will be available on demand later, I believe. So that's all for me. Thank you, and thank you also, Houssem, and yeah.
Thank you, Houssem, for taking the time to share your experience with our community. And I just want to share a couple of things with the audience and with the community actually today, and encourage them to take the Reactor survey once more, because this is a way for us to understand more the topics that matters to them the most. I'm gonna post all the links I'm gonna talk about in here. So on the survey, when you go on this link that I posted in the Q&A, you'll be required to enter the event code, and the event code for this session is 7787. So use that. We'll take some feedback from you about the session and the future sessions that you would like to see in the Reactor. So that's the first thing I wanted to share, and I wanted to share also a few upcoming sessions on the Meetup. So tomorrow we have a session on Python and Pandas that will be on manipulating and analyzing data, as well as learning how to split and join data frames. And on Wednesday, we will learn together how to get started, develop, deploy, and integrate with DevOps projects and code spaces. So it will be a getting started session on Visual Studio Code Spaces. And on Thursday, there is a session on building a location tracking app in Xamarin. So these are some of the interesting sessions that are upcoming. I encourage you to check out the Meetup as well link I posted in the Q&A, so that you can register for the upcoming sessions and you can join us. And also here are 3 other things that you can do to continue the journey. So first, you can subscribe to the newsletter. I put the link to our website in the Q&A, where you can go and register. And this is a monthly newsletter where we highlight some of the interesting events. We share you know, a lot of happenings that are coming from Reactor Abu Dhabi and from reactors in other regions. So we have a global presence, and it will be also good for you to join and subscribe to the newsletter to receive all these updates. And also there is a Microsoft Source. It's a regional newsletter as well for all the developer news and happenings and webinars and events. And we get our events there, and there are more to explore. So I highly encourage you to subscribe to that newsletter as well. And also I encourage you to explore Microsoft Cloud Society. There are lots of learning paths and modules so that you can join and watch those sessions so that you can also further your knowledge and expand in new technologies. With all that, I thank you again. I thank the speaker, Houssem, for his time today and sharing his experience, and we look forward to having you again in the future. And I thank you guys, everyone. Yeah, and thank you everyone who joined us today also on the session. The session, as Houssem said, will be available on YouTube for you to go back to and watch and reiterate on the concepts that were covered today. So stay tuned, and we hope to see you in future sessions, and make sure you join us for tomorrow and after tomorrow. We have lots of happenings that are like almost every day on the Reactor page. Just join our community, and we hope to see you soon.